Hello guys, welcome back to my channel, and today we'll be talking about the central tendencies in statistics. So let's start. So in last videos we have talked about what is statistics, what is descriptive statistics. We have understood like what is the population and sample and how it drives the descriptive statistics and inferential statistics. So this is the topics we are going to touch explain one by one. So today we'll be talking about measures of central tendencies, that is the mean median mode, and we'll also study why we need mean median mode. Okay, what is the role of them? So let's start. Okay, so before diving into the mean median mode, so let's start what is the motivation behind studying that one. Okay, so we'll start with one example. Okay, so in data science, when we start building any model or not model building, maybe when we want to describe some data, okay, or we want to analyze that data, okay, and then what we do, first of all, our data engineer write a data pipeline which will collect the data, or there could be manual collection of data, okay. So by some way we are collecting the data. Now we got this data. Now if you see this data, so there are some missing values like NaN. So in the second whole row is has missing values, or some places there will be missing values like NaN. Okay, so here in this fifth row only one value is missing, or there could be for example in first row this sixth column is missing. Okay, so this value is missing. Okay, in that column this value is missing. So there could be a multiple scenario, either whole row is missing or some of the values in some of the rows are missing. Okay, so now if you are building the model, then there will be need to fill those missing values with some value. Okay, so there could be some scenarios like you can remove that missing a row which has missing values, or you want to fill those missing values with some value. Okay, so there could be different scenarios. So that based on that there are different methods. For example, in pandas we have df.drop na. So this is a method. What it will do, it will simply drop the rows wherever it sees any na values are available. So for example, this row has na value, so this will be dropped, and then this second row will be dropped, this has na value, and then fifth row will be dropped. So basically first, second and fifth rows will be dropped and you will get this data. So it won't have any na value. Okay, or we can also give some condition like how is equal to all. So what it will do, basically it will try to remove na values with the how is equal to all condition, which means if in a row it will find all the missing values like this, then it will remove that row, otherwise it will not. Okay, so that's where it has generated this data. So it has removed the second row where we had all the na values, but it has kept this fifth and first row, and but still we have the na values available here. Okay, so now there are two scenarios, guys. If we want to go with this one, then of course we are removing second, first and fifth row. So by removing second row, you can say okay, all are missing, it's fine to remove. But if when we are removing first and 5 also, so only these two places we have missing value, but all other places values are there, it means we are losing lot of information by this, right? Losing lot of information, right, by this way. And if we are doing by this way, then what we are doing, of course the second row is getting removed, that's fine, but it has kept this first and fifth row, but it has the missing values. But with this we cannot move forward because machine learning will not understand this missing values. Then there is a need to fill these missing values. Then how you will fill those missing values? So that's where comes central tendencies, basically. Okay, central tendencies means central values. So the very basic guess to fill these missing values will be, suppose we want to identify what will be the age for this place. So what we will do, what is the average age of this column, and we'll fill that missing value with the averages of that column. Okay, for example, for a numeric variable. And then for example, we have a categorical variable. This sixth column is categorical variable. We have explained in the last video what is the categorical variable. So this is the categorical variable. So what, so here we will cannot directly use mean, we will use mode. Okay, we'll fill the mode is nothing but the frequently occurring data item, so the value which is occurring most number of the time, so we'll fill that. So this is the motivation, guys, why we need this central tendencies like mean median mode. So the main reason is to fill the missing values in the data set. Okay, so now with that context, let's understand how to calculate mean, how to calculate median, and how to calculate mode. So okay, so let's understand, and we'll tell some more thing there, basically when to use mean, when to use median, and of course when to use mode. Okay, so let's start. So the very first one, like mean. Okay, So suppose we have this data available with us. So this is like the runs scored by the batsman in 11 different matches. Like in first match he has scored 60 runs, second match also 60 runs, like that 70, 45 different matches he has scored these many runs. Okay. So what we can write, like 60 is appearing 2 times, so we can write this as a frequency table also. So 60 will come 2 times, 70 is appearing only 1 time, 45 1, 2, 3, 45 he is scoring 3 times, we will write 3, and 30 he is scoring only 1 time, so we will write 1, 81 also 1 time, 10 again 2 times, 10 is appear 2 times, means he has scored 10 2 times, we will write 2, and 25 1 time. Okay, so this is named as like frequency table. Okay, so either one is fine. So now based on that we have a mean formula. So this is our like 7th 8th standard formula, so there is nothing extra here, there is nothing new here. It's just like summation of all your numbers divided by total numbers, or like if it is given in terms of frequencies, then summation of frequency multiplied by that number divided by summation of frequencies. So you will see like 60 is coming 2 times, so like 60 into 2, or 60 plus 60, both are same, right? So plus 70 plus 45, so either you add 45 3 times or you do 45 into 3, both are same, right? So basically we are summing all the numbers and then summing the frequency and then dividing by frequency sum, then it will become like your mean value. So this is 43.72. so there is nothing new here, guys. Okay, so that's why I'm quickly covering here. Mean is like what is the difference between mean and median and how, when to use which one. Okay, so let's first understand what is median quickly. Okay, so median is also the median is also the central tendency. It tells the central behavior of your data, like what is the central data item. Okay, so for median calculation there are 2 ways. When n is odd, like when total number are odd, like total number of data items are odd and total number of data items are even. Okay, so based on that we have 2 formulas. Okay, if n is odd, then n plus 1 by 2th element, and if n is even, then n by 2th element, and n by 2 plus 1th element, take average. Okay, let's understand by example. If n is odd, then it is very simple basically, guys. So first you arrange this is the first step and then this is the second step. Based on what n is, you apply that formula. Okay, here n is odd, like 1 2 3 4 5 6 7 items are there. So first you arrange them in ascending order and then take the n plus 1 by 2th element. So 1 2 3 4 5 6 7, there are 7, so 7 plus 1 divided by 2th. Okay, what it will be, like a 7 plus 1 8 by 2, that is 4th element from the starting. So 1 2 3 4, so this becomes your median. Okay, now what about if n is like even. Okay, so for that we have 1 2 3 4 5 6 and like 6 elements. So first of all, what you need to do, you need to arrange them in ascending order. Okay, so we have arranged them in ascending order, and then what is the formula, like n by 2, so 3 3 6, so 6 by 2, that ts that element, plus 6 by 2 plus 1th element. Okay, and then you need to take the average of these two. So average means 1 by 2, what it will become. So third element, what is third element, that is 132, this third element, plus fourth element, that is fourth element, 146, right? And then average of these two, and that will be your mean. Okay, so it will become like 139. So that's where it will come here, it will become your median, 139 somewhere here. Okay, so this is your median. So this is fine, guys. Okay, so one important thing to note here is like mean and median need not to be in your data set. So now in previous slide when we calculated the mean, okay, what it came basically, so it came 43.72, and here you see in data set it is not available. Okay, so it is not always necessary that mean will be available in your data set. Similarly, like it is not necessarily that median will be available in your data set. Like when n was odd, so here we got like median was available in our data set. So most of the time when n is odd, so median will be available in our data set, but in case of even number, it may not be available in your data set. Okay, that's where 139. Okay, so this is your median, guys. And now let's understand with one example what is the difference between mean and median. Okay, so let's talk about some staff salaries in some random companies, so like 15k 18k 16k, like that. Okay, and then if you talk about the mean, so you can simply calculate the mean by previous formula, like the summation of these things and divide by total number. So mean will come 15.25. so what it represents here, so mean is means like on an average how much employees are getting paid. Okay, what is the average salary of employee, and if we say say like okay 15.25, then it is most of the salaries are around 15.25 or near to 15.25. That's what central tendency means, right guys? So here you see most of the employees are getting salary near to 15. It makes sense also, like 18, 16, 14, 15, 15, 15, 12, all are near to 15. So it's making sense. But what about two new employees join the salary which very high salary? For example, CFO or CEOs of your company joins the group. Okay. Now if you calculate the mean, then mean is coming like 30.7, and by definition of mean, that is average. So it tells like the on an average your employees are getting this salary. So if you talk about this group, okay, this whole group, so can you say like whether it is justified on an average employees are getting 30k salary? Is it? Even no one is getting close to 30k, right? Either they are getting in this group or very high. So that's where here you see like mean is not correctly representing your data set. So no employee is getting average salary as 13.7, right? Near to that, or not exactly, maybe near to that one. But here on an average people are getting 15 points. So this is like closely, right? So near to 15, everybody is getting near to 15.25, but here like 13 is not denoting the central behavior. So that's where here mean is not the correct representation. And now suppose we are calculating the median. Okay, so what it will be? So to calculate the median, first we will arrange them in ascending order, and then like how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data items are there, and it's even. So we'll apply that median formula, that n by 2th plus n by 2 plus 1th elements average. Okay, so by that we'll get 15.5. And now again you see guys, though we have two very high employee salaries available, but still our group average salary is like 15.5, and that is denoted by median. Okay, so this is the correct representation for this data. Okay, so that's where what these two are known as. These two are known as like extreme values, and they affect your data set, or known as like outliers. So that's where we say when we have outliers in our data set or very extreme values are available in our group or data set, then mean is not the correctly representation of central values. That time use median. Okay, so that's where like we have written. So median is used mostly when there are outliers in your data set. Okay guys. So this is the difference. So now when it comes to filling the missing values in your data set, so be careful whether you need to fill with mean value or you need to fill with median values. Okay. So now third one is like what is mode. So mode is like very simple. It is the most frequently occurring data item in your data set. For example, we have again salaries of different employees. So like there are 7 employees who are getting 100k, there are 1 employee who is getting 345k, there are 10 employees who are getting 1000k, there are 2 employees who are getting 9833k. Okay, so basically then what will be the mode? So here you see like okay, 1000k is appearing 10 times, so that's why this will become your mode. So mode will be 1000. Okay, so like frequently occurring data item. So again guys, the 3 important point, mode is used in categorical data set. For example, when you have missing values in your categorical data set and you want to fill those categorical values, then you go with mode. Okay, filling missing categorical value, you go with mode, and mode will always be present in the data set. So guys, if you are appearing for like some screening test and there is some objective kind of question, then this question might come, okay, in your paper. So mean and median need not to be in data set, which we have already seen. Okay, so this point is very important. Mean and median need not to be in data set, but mode will always be present in your data set. Okay guys, so keep that in mind. So that was about mean and median, and let's take one more example guys. So there is a company who wants to give all employee a raise. Okay, so it could be a yearly raise. Okay, and now they are unable to decide whether they should give a straight 2000 hike to everyone, or they should increase salaries by 10% across the board. Okay, across all employees. Okay, so they are confused. And now what else information we have? Like current mean salary of total employees is 50,000 and their median is 20,000 and their mode is like 10,000. Okay, so average salary is 50,000, the central value is like middle point is 20,000, and mostly employees are getting 10,000 salary. Okay, then how do these central tendencies change in both cases? For example, if a company decide to give 2000 hike, then what will be the effect in these 3 data items like mean, median, mode? and if they are giving a 10% hike, then what will be the change in these three entities. Okay, let's see. So I have written this solution basically, but you can solve it like how you will solve. So let's see. So for example, the current mean is like 50,000. Okay, so current mean is 50,000. So suppose there are n employees. Okay, n employees in your company. So and we want to know the total sum of the salary. So what it will be like, mean into total number of employees. So this will be your total sum, right? So this is the total sum of the, and if they want to give the total hike of 2,000 for each employee. So first employee will get increment of 2,000, second employee will get increment of 2,000, third employee will also get increment of 2,000. So overall increment will be like the burden on company will be 2,000 into n. So this is the extra expenditure, right guys? So let me get this thing. Okay, so if you do like 50,000 n plus 2,000 n, and number of employees are still n only, right? So what it will be? So now what new mean will be? N, you can take 50,000 plus 2,000, right? And divide by n. N you will cancel out. So new mean will be 50,000 plus 2,000. So mean will be incremented by 2,000. That's where I got 52,000, right? Similarly, if you will apply the formula for median, then median will be incremented by 2,000. So new median will be 22,000 and new mode will be 12,000. Okay. So because that 2,000 will be applicable to each data item, and that's why it will increase the middle point also, and it will be incremented by 22,000, and the mode will be become 12,000. Okay, these are the new salaries, new central tendencies. Okay, now what about if he gets 10% increase? Okay, if he gets 10% increase, then like every data item will be incremented by 10%, and similarly your mean point will also be incremented by 10%. Okay, so you can increase every data item by 10%, and then you can put into the formula, and then you will see. So what will happen, like 50,000 and 10% increase, so 10 by 100 and 10, this is the increase, right? 100, then you will sum, you will add in the previous data. So this is the total mean value will after increment. So it will be like 50,000 into 110 divided by 100. So this is the increment. Just solve this and it will become 55,000. Okay. So if he is giving, so this is normal mathematics, right? Simple, very like 5th or 6th standard math. So I'm not solving everything, right? So you can solve easily. So like a 10% increase, so new mean will be 55,000, new median will be 22,000, new mode will be 11,000. So see, there is a more increment in mean salary. Mean salary will increase by like 5,000 in this case, and here it will increase by 2,000 only. And median will remain same in both the cases, either 2,000 either they are incrementing by 2,000 or 10%, both cases it will be 22,000, but mode is 11,000, here in this case 12,000, right? So based on that you can decide if you want to look for the average salary. So average salary here is 52,000, and here average salary will become 55,000, right? So maybe company want to go with like 2,000, right? Increment will not give 10% increase, right? So that's fair. So that's how you can take a decision. Okay, but this decision like depend on various other factor also. But if you talk about on normal mean median mode, then okay, of course the mean salary is getting incremented by 5,000 here, but here increment over only 2,000. So that's where maybe completely decide to go with this 2,000 increase. Okay. So guys, that's all about mean median mode. That's your central tendencies, and in next video we'll talk about the measures of variability and spread. That's where it comes like variance, standard deviation, range, quartile, interquartile range. Okay, so that's it. Thank you for watching.